Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem based on the concepts of cosine function model. So as per the problem, the planet Venus orbits the Sun every 225 days. Now, because of its elliptical orbit, the distance between Venus and the Sun periodically increases and decreases. The maximum distance of Venus from the Sun is 108.9 million kilometers and the minimum distance is 107.5 million kilometers. The sinusoidal function d at t equals a cosine of b at b times t plus c models the distance in millions of kilometers as a function of time t in days. And Venus is at its maximum distance from the Sun at t equals 0 days. So let's start with part A. So find the values of constants A, B and C. So as we can see in the given equation, A, B and C are the constants that cause the transformation of the parent cosine function. So let's start with the A value. A value can be calculated using the amplitude formula. So the formula for amplitude is amplitude equals the maximum value minus the minimum value over 2. Now as per the problem, the maximum distance is 108.9 million kilometers. So amplitude, so 108.9. Now since the unit of distance is millions of kilometers, so we do not have to change 108.9 million kilometers to 108.9 times 10 to the power 6 kilometers. So the minimum value is 107.5 over 2. Now we can evaluate this expression. So it's 1.4 over 2, which is equal to 0.7. So the A value is equal to 0.7. Now we can calculate the B value. So B value can be calculated using the period. So for this sinusoidal model, the period is 225 days because it's given that Venus goes around the Sun every 225 days. So the formula for B is B equals 2 pi over period. So now we can subtract for the period, and so this can be the exact value of B. Now we can calculate the C value. So for C value we can use a formula, and the formula is the max value plus the min value divided by, so it's 108.9 107.5 over 2. Now we can add the numbers in the numerator. So we get 4 decimal 6 1 1 and then 2 over 2, which is equal to 108.2. So this is the final answer for the value of C. So these are the steps you have to keep in mind to answer part A. Now we can answer part B. So in part B, we have to find and interpret the average rate of change of the distance over the time interval when the Venus is at its maximum and minimum distances from the Sun. Now, as per the problem, Venus is at its maximum distance from the Sun at t equals 0 days. So that can be written as an ordered pair. So at t equals 0, the Venus is at 108.9 million kilometers. Now, Venus will be at its minimum distance from the Sun halfway through its full cycle. So halfway through the cycle will be 225 divided by 2 days. And at that time, the distance from the Sun will be 107.5 kilometers. Now 225 over 2 can also be written as 112.5 and then 107.5 million kilometers. So these are the 2 points that we can use to find the average rate of change. So for that we can use the slope formula. So average rate of change. So we can label the first point as x1, y1. We can label the second point as x2, y2. So the average rate of change formula is y2 minus y1 over x2 minus x1. So we get 107.5 minus 108.9 over 112.5 minus 0. Now we can simplify this expression. So in the numerator, we get negative 1.4 divided by 112.5. Negative 0.0124 and the unit is million kilometers per day. So that means the Venus is moving closer to the Sun at this rate. So now we can write this interpretation, because in part B we also have to write the interpretation. So the interpretation is, so Venus is moving towards, moving, or I would say closer to the Sun. At the rate of negative 0.0124 million kilometer per day. So this can be our interpretation. So now we are done with part B. So now we can analyze part C. So as per part C, we have to use the average rate of change to find the distance of Venus from the Sun at t equals 40 days. So the first step is to use the average rate of change to find the distance Venus will get closer to the Sun over the period of 40 days. Now the rate of change tells us the distance the Venus travels or gets closer to the Sun every day. So the first step is to multiply that rate by 40. So I got 0 point or negative 0.496 million kilometers. So that's the distance Venus moved closer to the Sun. So the distance from Sun will be equal to, so the maximum distance from which Venus started, because that's the starting position, so it is 108.9 and minus 0.496, because from t equals 0 onwards, Venus moves closer to the Sun. So now we can do this calculation. So I got 108.4. So I'm rounding the answer to one decimal place, and then million kilometers. So this should be the final answer for part C. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.